So actually, let's come up with an approximation for cos of x. Let's just change this to cos of x. Let's do question 1. Okay. So effectively, what I'm saying here is finding a Taylor series approximation. Find me a polynomial which matches cos of x around x equals 0. Okay, that's what I'm after. So I just think about what's happening over here. Just think about what's happening over here. So if I want my first approximation, I would just consider C naught. Okay. Now, who can remember what is C naught? C naught is just what happens when I stick my value x equals 0 into my original function. If you remember, it is just simply approximating it as a single point. It's a rubbish approximation, but it's just at that point there. Okay. So C naught is just what happens when I take my function and I stick 0 in. In other words, when I stick 0 into cos of x, I get 1. So in other words, C naught is just 1. Okay, so I could write this underneath. C naught is just 1. Okay. If I want to consider more terms in my sequence, my series, I would now consider a linear term. In other words, I consider this as a straight line. Okay. So in other words, I need to find what C1 is. Well, if I look over here, it tells me C1 is just equal to what happens when I differentiate my function and stick x equals 0 in. In other words, the value of the gradient should be the same at that point. Okay? So in other words, this should just be equal to f prime of 0 in this case. Okay? Which, of course, is just equal to what? Yeah, because it's sine of 0 and then negative of that. Yep, that's fine. Okay? So sine of 0 is equal to 0. So in other words, I get plus 0 times x. Okay? Now, if I want a better approximation, I would consider more terms. So I'd say, what about c2 x squared? Well, c2, if I look over here, c2 is just equal to, well, 2 times 1 times c2 is my second derivative of my function, then I stick 0 in. Okay? So in other words, c2 should just be equal to the second derivative of my function, and I stick 0 in. And then I divide by 2 times 1. Do you see that from over here? Like I'm just dividing by my coefficients here because I don't want all of those. Okay? So in other words, f double prime of 0, well, cos of 0 is 0. Sorry, cos of 0 is 1. Make it negative, it becomes negative 1. Okay? So it's going to be negative 1 over what is effectively 2 factorial. So it's going to be negative 1/2 times x squared. Okay? And then if I go for one term further, so I go for my cubic term as well, then I just need to find out what C3 is. So C3 will be what happens if I take the third derivative of my function and divide by 3 times 2 times 1, divide by 3 factorial. Okay? Oops. So I'm going to take my third derivative of my function, stick 0 in, and then divide by 3 factorial. Okay? So are you happy that the third derivative of my function is sine? Stick 0 in, it comes out as 0. Divide by 3 factorial, it doesn't matter. It's just going to be 0 times x cubed. Is that okay? So if I do a bit of tidying, what I'm literally saying here is that my function can be approximated. So cos of x around x equals 0, the first 4 terms can be approximated as 1 minus 1/2 x squared. Okay. Now I just said the first 4 terms. Is that strictly correct? I think it depends. Okay, it depends how you define the first 4 terms. Because yes, we have definitely considered up until x to the power 3. So we have considered 4 terms, but I've only written 2 down. So if I do want 4 terms of my expansion, I'm going to have to keep going. Okay, so I'm going to have to do the x to the power 4 term and the x to the power 5 term. So what I need then is a way of generalizing all of these ideas. In other words, what is my Taylor series equal to? Can anybody remember, or approximately equal to? Can anybody remember what my Taylor series expansion is approximately equal to? So can you take these ideas and can you summarize them in sigma notation? Around some point, let's go x equals 0, yeah. Okay, so sum, we start at 0, k equals 0. Yeah, f.
0, node k.
So this k up here corresponds to the derivative I'm interested in, okay? And that kind of makes sense with what I was looking at on this side of the board over here, okay? So I basically look at my kth derivative, then I stick 0 in, okay? Then I divide by what? Perfect, and that corresponds to the fact that every iteration of my derivative, basically the power keeps climbing down. So, for example, here, I started with a 2 as the power, and then the next term became 2, and then the next term became 2 times 1. And you can carry on like that, okay? And then I times that by whatever term I'm interested in, so my x to the power of k term, okay? And that's what it is equal to.